Everyone, this is Eric with Bobcat Tech Support. I'm the demo tech normally with Bobcat, so I do the support questions for any customers, and I also do demonstrations of the software program. Also here live with you guys doing the webinar today, the live event on advanced cam features, mostly for 3-axis milling here in BobCam for Rhino. Version 3 that's out now. We also have some other plugins available. One is for SolidWorks. We're up to Bobcam for SolidWorks V10, and we're also on our standalone Bobcat version 35. And each of those, if you have any of those plugins, I guess you could say, either the standalone Bobcat for version 35 or the plugins SolidWorks V10, or here that I'm in today, Bobcam for Rhino V3, you can follow along and be able to see the cam portion that we're going over today in any of those versions. So we'll be going through some cool some advanced cam features. This one we're getting into 3-axis premium from the start, looking at premium toolpath for deburring that we now have. And we'll be able to look at that. We'll be looking at some other features that's located on this page that you're at now. We have a description of what we're going over today, deburring, some other advanced features like the dynamic holder checking, so some options to check the tool, make sure there's not going to be any collisions. A lot of neat tips and tricks to be able to make sure there won't be any collisions when it comes to programming for your machine in milling, and being able to get the right depth of cut, get the right step over, and the right parameters to what you need for your milling job. So we'll start here in Premium. I'll go to my page here. You can see that we have a couple deburring operations here with the holes and the side of the part here that we're looking at specifically. And we're going through the milling job, defining our stock, and defining our machine setup down here at the bottom of the part here. So once it's all roughed out with this one, the holes are drilled, and we want to do an edge break, that would be in the Premium, where I can right-click on my machine setup and go to my different milling operations. We have our drilling and tapping operations, 2.5-axis machining, and 3-axis milling for our standard and pro features. Then when we get to our Premium, that's located in our mill multi-axis option here. So I'll go here to our different Premium toolpaths that offer the wireframe feature. That should be in 3, 4, and 5-axis milling. Deburring is also in 3, 4, and 5-axis in the Premium. And then our surface-based toolpaths are also in the 3-axis Premium that offer these surface-based toolpaths to make sure that it will create an even step over all the way across surfaces that you select. These other options are more for multi-axis. The turn milling is for 4-axis roughing around a rotary. We also offer with 5-axis milling port machining now. Multi-blade. We offer multi-axis machining for roughing and swarf machining along sides of 3D models as well. So to get that out of the way with our different surface-based toolpaths here in the mill multi-axis, we go to deburring, which again is in the 3-axis Premium, also in 4 and 5-axis Premium. deburring. And our next page, we're setting our work offset number. Number 1 is G54, 55, and so on. If we're setting up multiple work offsets there at the table. Then we're defining our tool. If I have it as a flat end mill, it will come back with an error. It should error out once I compute, because it wants a spherical tool is what it says. So what I need to define it as is either a ball end mill, like I would have here, a 1/4-inch ball end mill, or if I go to the tool library, go to the lollipop section, the different lollipop tools we're also able to uh, define for these operations. I'll stick with the 1/4-inch ball end mill just for this demonstration here. Next, we would select our part surfaces. So normally what I do is I select solid body and select the full solid model. And then that way we can either let it auto-detect all of the edges that it can do the deburring with, or I can select this drop-down and select user defined. And then I can just define certain edges that I'm going to be doing this deburring operation for specifically. Next, we can set either a constant width of the deburring operation or a constant depth that I'm going down into the corners that I'm breaking. And with inner corners, we have this trim or relief option, where you can see into this corner, the relief is actually going in a bit further than the relief will detect it based on from the corner, or trim will detect it just based on the length and the width of the diameter, the width of the tool there, diameter. Then number of cuts along edges, so I can do multiple passes across the basically like a step over and step down with the deburring. We have an extension option, so basically a lead in and a lead out, where I'm starting and ending the operation there. Our next page, you can see these different tabs here instead of the different pages. So our next tab here would be tool axis control, whether I'm doing 3-axis. I could do 4-axis around a rotary, 4+1, 3+2, or 5-axis simultaneous machining with this deburring. Now again, that's depending on what you have with your package of milling. If you have the 5-axis premium, it would unlock the 4-axis and 5-axis machining types here for deburring. Now you have some clearance options here as well that we'll get into later, specifically with the holder clearance, arbor clearance, shaft clearance, to make sure that we have a certain clearance area between the geometry of our tool and our tool holder and the geometry of the stock that we're machining from. Then we've got fixed tool contact, so a certain amount for the tool contact there. If we're using the side of the tool here, for example, we can go halfway between. If we're set, this is going to be more for, you can see like a multi-axis option using the side of the tool there. Linking for each step over. If we're retracting to a certain clearance area, a clearance plane between the holes here, for example, and the side of the part. So let's backplot this. Again, the 3D model is what I defined for my shape, and then the user-defined edges would be just the 2 holes here and the side of the stock here to start with. We'll backplot this. Yeah, so with this one, in our new versions, we've got the spherical tool of the ball end mill lollipop tool, and now we can also work off of with V tools, chamfer tools here, to do a chamfer along the holes and along the sides here. Depending on how I select my geometry, you can see I selected the hole first, this hole, and then the side, and then the second hole here. And you can see that certain width right there. It's dependent on what I set under my parameters, my constant width of 20 thousandths of an inch. If I change it down to 10 thousandths, do half of what I had before. You can see the toolpath updates, and I can right click on the deburring operation under the feature. So the feature is the group of operations that we have, and there's only one deburring operation under this group. And I can right click on the deburring operation, go to backplot, and I can just move the progress bar over to get to that last hole, and then step through. It's very convenient, this backplot, where I can see the current tool location. I can view just the tool, flute, the shaft, the arbor, and the holder. I can turn off and turn on. If I zoom in, I can see the different width. It's half of what I had before of the 20 thousandths versus the 10 thousandths there. So yeah, I think that's it for the deburring. We'll be looking at next. We'll be looking at the premium option. One feature that I really like in there, in terms of the advanced cam settings that we are able to offer, and I'll look at our comments section so far. Yeah, no comments yet. If you guys have any comments while we're going through the demonstration or the live webinar event today, you can please type in any comments that you have, any questions, and I can answer them while we're doing the webinar today. Anything that you have pertaining to recent weeks. Also, we've gone through 2 and 3 axis milling in BobCam for Rhino, and we're just moving right along in the plugin for Rhino currently on our schedule. And so we'll go to, let me go back to my page. Okay. Yeah, so no comments yet, but yeah, if you guys have any comments or questions, please let me know. I'll answer any questions that you guys have here in the plugin for Rhino. And we'll go back to the premium toolpath options under mill multi-axis and under surface for our surface-based toolpaths. Any of these features here under our parameters page, as I was explaining, it will create an equally distanced step over from one edge of the surfaces you select outward to the last edge. You can set your step over accordingly, or you can set your cusp height here. This is a really nice feature here in the premium 3-axis toolpaths, that you can define your cusp height or scallop height, as some people refer to as, or your tolerance level. And you can see right now it's set to 2 thousandths of an inch cusp height. If I change this, maybe if I change it to 1 thou, you can see the number above it, the step over, will automatically update because these are both interrelated. You've got your cusp height here, and if it's 1,000th of an inch, it will change the step over from 50 thou to 31 to achieve that desired cusp height or that desired tolerance you want of the surfaces you've selected for this finish operation. And again, with tool axis control, you've got 3, 4, and 5 axis for this. This will be in the 3 axis premium, and then 4 and 5 Pro options for your surface-based tool pads.
Hey, Eric, how are we doing today?
Hey Al, how's it going?
It's going pretty good.
So glad you're able to join us today. And so far, I've really just kind of gone through the deburring options that we have with this part file, and then kind of with the premium, explained some nice tips and tricks for anyone that didn't have that feature. Showing the step over, desired cusp height, and things like that so far.
Hey, can you do me a favor, Eric?
Uh-huh.
Can you, because I kind of wanted, I know last week we covered a couple topics as well, and one of them was picking the start point. Do you have that Coke bottle example?
Let me see.
See if you can open that one up, because I think there was one that had all of the toolpaths already set up. And while you're looking for that, maybe I can go over the new training event that we have going on
Okay,
at the end of this month.
sure.
Okay.
Yeah, and do you happen to know the name of it? I don't know if it was
Uh,
3D
no,
template.
not off the top of my head. I'll see if I can share that with you as well.
Okay.
So at the end of this month, we do have a training event that's coming on, and it's the first of its kind over here. You know, Bobcat's done 3-day training seminars across the U.S. We've trained over 10,000 people on the Bobcat software in cities around the U.S. and around the world. But most of the advanced training really has been limited to, those where we come on site, or for people who come in house. So I know this year we're doing less training events. So I believe there's 6 cities that we picked, and the other months, instead of holding a local training event, we're hosting these advanced training events in our office here in Tampa. Okay. So for those that are unable to come, and we have limited seating, I think there's about 12 people that 12 or so that we can accommodate for. We do have two rooms, but this is an advanced training seminar that we're doing in house, but we're also streaming it live. Okay. And for those of you that maybe wanted to get some advanced training, maybe you've done one of the 3-day seminars in the past. And that's how you keep up with the software. I definitely recommend this one. This is for 3-axis machining, and it's really going to take a deep dive into some of the more important areas of the software and really how to unlock its functionality. This is listed right on our website here. You can call your account manager for information as far as like attending, or you can also contact um, our training director as well. It looks like this is a $1,000 event if you come to the office here, or if you're looking for the streaming of it, it's $500. This is 3 days, so you will get the recording of it as well. So if you guys are considering some training and you'd like to come to Florida right after spring break, this might be a great time for you to do that and to take this additional training. Now, we've had really, really good success with people coming in house. I'm sure you've seen some of the videos of some of the amazing things that we've been able to do. Lua scripting and some advanced functionality, the new MDI programming blocks. There's a lot of things that we have going on in order to really kind of help um, you guys get better results and get results faster and take advantage of the software most. And a lot of times, within the last couple versions, there's over 200 features that we've added to the software. And a lot of times these go unknown just because you guys haven't gone to the training events, or you're not reading our blogs, or maybe you've just been busy. Okay, so make sure that when you do have time, you either watch the recording, read the blogs, or jump on live with us so you can ask us questions. And again, just as a recap of last week, one of the topics we talked about was the start point control. If we go in here to the advanced rough, you can see how it's starting over in this corner. Okay, sometimes you may want the tool to start in a different area of the part depending on the operation. Could just be preference. It could have to do with the tool marks. Okay, so if we were in the advanced rough and we wanted to move this, I believe we can go to patterns. We can enter a value or pick it up off the screen, be able to grab a different location. And then you have to recompute it to update it, and you'll see how now it will switch sides. Okay, so instead of it being in the back corner, we now have it in this corner, right? Okay. Advanced Z level finish offers this as well. Again, if we want to change its starting position, I'm pretty sure. Well, I guess this one's under links. Let me see. Where is this? Parameters. They're typically either under the patterns section here or the links section. So I forgot where this one is right off the top of my head. Let me see if I can find it. Links. Okay, yeah, this one is links. Linking position, starting location, pick. We're going to just pick on a different side of the part. We'll say okay, and again, we'll recompute it. Okay, and we'll see how the starting position will change. On this part here, we would really want more of a vertical part to see this, but again, in advanced rough, it's under patterns starting location. Okay, with advanced Z level finish, it's going to be under the links section starting location. Okay, now this is also available for advanced planar, equidistant, and pencil. And that was one of the big takeaways from last week. Eric, was there another big takeaway that we had from last week that you can remember?
Trying to remember. Yeah, start point options. I think we went over rest machining.
Okay.
Was a nice takeaway from the 3-axis milling from last week.
Okay, perfect. How do if I was a user and I was attending this event, Eric, how do they let us know what they want to learn about? What would they do?
You can go to I believe it's on bobcat.com, right? Not on our support portal.
I mean, chat. You work
Yeah.
chat, I work chat, so you
Yeah.
could ask us questions on chat. I think our user forum is another good place to communicate about things, but probably the surveys that we send out, right? That's
Yeah.
probably the best way to communicate what you want to learn more about. Or you could always email. You could email us at uh, training at bobcat.com, or my email is al at bobcat.com. Eric, what's your email?
So my email is a bit uh, more complicated. Maybe I should get an easy one like yours out, but mine's maybe I should get an additional one for training. But it's my first initial and last name, so it's eseckler at bobcat.com.
Maybe just put it in the chat to make it easy.
Sure.
So that'd be a good idea. All right, so that's a little bit about this file here. Why don't I pass it back to you, and then you can kind of pick up where you left off. So you said you covered what have you covered so far? The chamfering.
Yeah. So far the chamfering, and yeah, I was kind of branching off from that and showing premium as well. The cusp height for your step over option, how those are related to each other. I don't have that bottle mold though, or the bottle.
Don't worry about it. Just go back to the chamfering example,
Okay.
because there's probably some things that we want to hone in on. So if you're with us, whether it be on YouTube or whether it's on Facebook, if you're on the blog post or our live training page, you got to get to the live training page to chat with us. So just follow the links until it says join us live, and then click there, and then you'll see the chat. And from there, you can communicate with us and ask us questions, right? Okay.
Yeah.
So, one of the things that I know we want to cover, if you want to get your screen going again,
Yeah.
Eric, and pull up that chamfer example, would be the chamfer, or the 3-axis edge breaking, right? Comes up all the time. It's actually super easy to do. Did you show? I guess we didn't have a chamfer in there. I like the manual method. What do you find yourself using the automatic method or the manual method more often, Eric?
More of the manual so that I can manually select the different options here.
All right.
Looking on how to, because there's like an
Get your
ad.
screen again.
Yeah, there's like an ads. Oh, here we go. I think I've got it. It's a new option here with the.
Yeah. We'll get better, guys.
There we go.
Bear with us. We'll get better.
There you go. Yeah, there's a new option there in Vimeo to, you have to add a scene or something like that. So kind of weird, but yeah. So I've got the chamfering
I don't think you're
file.
displaying
Uh,
just yet.
no, okay.
No.
Showing that it is on mine. Oh, let me try again. Okay,
There
how
you
about
go. Now it
now?
is. Now it
Cool.
is. Yep.
Alrighty. So yeah, other options you wanted to go over with this file, Al?
Yeah. Pull up
Um,
one of the ball mill.
the one with the ball mill was, I believe, this one, right? Yep.
Mm-hmm. Okay. There's really two things that we're kind of showing here. One, that you can break a 3D edge. And a lot of times when you have like through holes on contoured surfaces, this comes up a lot, right? So
Mm-hmm.
anytime you have a curved surface and you're trying to break an edge, to do it evenly, you can't just use a chamfer tool in a 2D routine. It's got to follow in 3D. So that's why we use deburring.
Mm-hmm.
Now, right now with the ball mill, we're taking a single pass, and you can see it will support shallow surfaces and even steep surfaces that have holes through them where you're breaking the edge. And that's really what we're showing here, is both steep and shallow areas of a 3D surface. Now, the way you're doing it right now is where it's just taking a single pass, but there's a new serialized or spiralized option. Can you, where is that? So if we're in deburring, where is that new spiralized option?
That's a good question. So I believe it's under some of the parameters. Is that right?
I would imagine, but I know we need to add multiple passes. Right now it's only doing one pass.
Okay. So you're talking about the cuts
Mm-hmm.
along edges. We have
Yep.
flat and we have rounded option as well here.
All right. So so whether it's flat or rounded, it will have like a multi-pass option there. So right now it's set to 1, so it's only trying to break the edge with one pass.
Mm-hmm.
If we add a number to that, then it will try to do multiple passes, right? So let's make it 5, for instance, and we'll recompute.
Okay.
So now what we're going to end up seeing is multiple passes to come in there when you display that tool pass. So you might want to blank out the other items
There we
and
go.
only display that one. And then maybe backplot it so you can see that there's multiple passes on there. Now, one of the things that we try to eliminate is like up down motion of the tool. So like if it's in the cut, we want to keep it in the cut. Right now it looks like it's doing one pass on each and then going to the next.
Mm-hmm.
So if we had a bunch of parts if we had only one of these to make, probably not the worst case scenario, right? But
Yeah.
if we had a bunch of these to make, this added cycle time, right? So I think if you go in there on those multi passes options, you'll be able to see a spiralized uh, checkbox or something to be able to go in and edit it, right? So we would edit the feature, we would go to the parameters, and then
Linking, you would think.
no, I think it's going to be under patterns. I don't have it open. I'll open it on mine so I can help assist. I can't on the screen here. It's kind of hard to see exactly
Oh, gotcha.
on my side on the resolution.
Right. Right.
But
Oh yeah,
okay.
there's a checkbox for spiralized closed contours.
Okay, so one of the things about these events that are really important is we want you to leave with information that you can use, and we want to make sure that it's something of value. And breaking edges is something that everybody can use, and it's something of value. Okay, so where is the option is important, what it does, what is it supposed to do, and then how to use it. Okay, so if we're saying this, let's back up, Eric. Let's
Sure.
exit out of this this toolpath for a second. And
Okay.
if you were going to and blank out the toolpath, so the first one is, where is the deburring toolpath? Where are we going to find that?
Yep. So if we right click on machine setup one and go to mill multi-axis, as I was getting into the very beginning of the webinar here, we've got drilling, tapping, 2-axis. Our mill 3-axis offers the standard and the pro features under your 3-axis milling, and then your 3-axis premium is under mill multi-axis. That gives you the premium toolpaths of your surface-based toolpaths, deburring, and some other multi-axis for 4 and 5-axis premium.
Okay, so if I'm a Bobcat user and I want to use deburring,
Yeah,
I need to be a mill premium user. Is that correct? Okay.
correct. Yeah,
And then in order to find it, I'm not going to find it under the typical 3-axis toolpaths. I'm going to find it under mill multi-axis. Okay.
right.
All right. So let's create a new one in here. Now, I know with your license or my license, we have full licenses, so it's 5-axis software. When
Right.
you get mill premium, there's a step we have to take because we have 4-axis simultaneous and 5-axis simultaneous licenses turned on, right? But if you're just a mill premium user, you won't have to worry about the axis control. So if you just show them where that is real quick.
Yep. So after selecting deburring, our next page is our work offset number page for posting, and then the tool page. And then the very next page, we have different tabs here where we have our surface paths where we select our geometry. And then
Right.
the next tab is our tool axis control where we would change it from 5-axis to 3-axis in hours. And I believe, like you were saying, it would just normally be 3-axis by
If you're a
default.
mill premium user, it will be defaulted to 3-axis. You won't have access to any more. But if you're a 4 Pro or 5 Pro user, you're going to use that drop down to change which mode it's in. Can you show some of the modes there real quick?
Sure. So we have our 3-axis. We have 4-axis for a rotary, 4 plus 1, 3 plus 2 for 5-axis indexing, and 5-axis simultaneous.
Okay. So a couple of different options. We'll have to go over those as we get into those training events later this year, right?
Right.
Okay. So we're going to leave that on 3-axis. If we go back to the surface pass here, I know there's two options. There's two scenarios. One where you have, you know, a chamfer or a fillet already modeled on the part, and then you have another scenario where you don't have it modeled on the part. Okay, so in our example, we don't have it modeled on the part, and if you're in control of the design process, you know, it's easier to program it this way without the chamfers, right?
Mm-hmm.
Okay, you select the edge, you select the model. Now, if the chamfers are on there, like if you already imported a file, the workflow is a little bit different. If you're importing a file and the chamfers are on there, it came from the customer, at that point, the way you define those edges is a little bit different. And I don't think this file is quite prepped for that today. So if you guys would like to learn more about that, make sure to comment in the chat section so we can pick it up, or email Eric or myself. And we'd be more than happy to add that as another topic. Okay. All right. So just go through the whole thing, Eric. So just kind of uh, walk through the steps
Mm-hmm.
and get the toolpath on the screen.
Yeah, so normally with the part surfaces, I would select the solid body. Now with the solid body option,
Yeah.
okay.
So
Now, do you
so
have
for
something
yeah,
with
I
that?
got a little bit of feedback here. So
Okay, yeah,
this model I drew in Bobcat and then brought it into here. Okay.
gotcha.
And I saved it as a step file.
Okay,
And um, I noticed that when I went to select the geometry, maybe the way that Rhino reads the geometry is a little bit different, because normally we have this checkbox for is solid or is not solid. So what I did is I unchecked that and window picked it, and I was able to get everything in there in the screen. Okay.
gotcha. That
All right.
makes. I was wondering why the solid body wouldn't select, like you said, probably because
Mhm.
it's step file. But yeah, selecting the
I don't know. It may just be the way Rhino sees that geometry. You know what
okay,
I mean? So just
yeah, yeah,
something we'll have to look at more as we go. I think if you're a native Rhino user, you're going to be more familiar with the geometry, bodies, and types. Okay.
Okay.
All right, keep going.
So then next we've got our edge definition. We can let the software detect all of the edges that we could possibly do an edge break on. We have an advanced page as well where we can set certain parameters depending on what certain edges we want to break. And then we also have user defined, which is a manual option. And the next button here is where I can click for user defined edges. And I can select just the edges here that we had before. So this whole, oops, and the side of the part here as well. And then click OK. Then we have our constant width where, or constant depth option here. It's normally set to 20 thou. We can change it here. Maybe if I wanted to change to 10 thou. Uh, we have a trim or relief option. Do you have any feedback on that, Al? I was wondering, kind of curious on the different settings that we have for this. Trim or relief. I see the additional arrow here, like basically going in, detecting the certain radius depending on the corner versus the center of the tool and the side.
Yeah, so what the graphic is showing there is whether it, does a radius before the corner or whether it bisects the corner, like intersects the corner as
Right.
like a relief. So
Gotcha.
generally my approach with the multi-axis strategies is you leave the defaults as is,
Mm-hmm.
work on the geometry selection. There are a couple
Mm-hmm.
of clearance things that I usually default, but I try to leave the defaults. And then, if there's a scenario that comes up, like the toolpath isn't doing what I want or what I expected, then I'll go in and adjust one thing at a time, you
Mm-hmm.
know?
Right.
So what can happen is you could start editing a feature and you can get really lost. What was working? What wasn't working? What did I do? What didn't I do? So, we have a workflow that really helps with that, and that's when you use copy and paste. And what I'll do is I'll request the screen real quick, and I'll show an example of it of
Yeah.
how I did that, because this is really important, because making changes and working through designs is really how you get better at things, right? How you
Right.
improve. And the idea is definitely to improve things, right? So we have our multi-axis deburring here, and you can see we have our toolpath set up, but maybe what we want to do is either try a different tool or try a different setting. Okay. So instead of creating a new feature from scratch where we would go down and have to answer all the questions, we want to take what we have set up, and the selected geometry, and iterate it. So we're going to just right click on the feature and do copy with geometry. Okay. And then we'll right click on the setup or the feature, and then we can do paste. So now we have an exact copy of this with the same toolpath and geometry selection set up. If we recompute, we'll get the same exact thing. But the best part about this is now we can keep the original one here, and we can come into this one, and then we can work with the settings, right? So, okay, well, what does it look like when there's three of them? You'll notice as soon as you change this from 1 to 3, this spiralized option comes up, right? So let's just change it to 3. Okay, anytime you make a change to the dialogue, in order to update the change, you have to recompute. So we recompute, it'll take a moment to calculate. Now we can see we get multiple passes. Now the thing is, we have two different features on here, so we do want to make sure that the only one we're looking at is the one that is active, right? Or that we just edited. And that's where you'll see this extended cam tree. Eric has his on the left, I have mine on the right. You can use this to turn the visibility of a feature on or off. You can use the post yes no option right here. Okay, so that way you can make sure the one that you're visualizing here is just this particular routine. Okay, another thing you would do is maybe run simulation. So you have back plotting to visualize what's happening here. Okay. But you also have solid simulation. So based on what's active in the tree, and what I mean by that is you can turn off features so they're not part of simulation. But based on what's active in the tree, you can run a simulation. So then not only can you backplot the toolpath, um, on the cat in the cat interface, you can also run this through simulations to verify, collision checking with additional machine components, but also the part and the stock. In this example, I don't have any of the stock roughed out. So basically, we can't really tell what's going on. Now, we could turn the stock off, and maybe just show the workpiece, but we have to make sure that the workpiece is defined in order to have that visibility to turn it on and off, right? So I'll come back over here. You can see a red plus indicates that it's not selected. So we'll right click, reselect. I'm just going to window pick all the geometry. Um, I guess it really doesn't like this model. I don't know. I don't, or it might be a selection filter that I have on too, because it
Right.
appeared that yours was selecting it, and I'm not seeing that right now. But that may not be why that's coming over. But let me see if I can select it as a stock body, because right now one of the tricks that I'll use when I'm doing semi-finishing or finishing is to use the workpiece as the stock body, so I don't have to worry about roughing and seeing all the rough stock material. So the way that I would normally do that is to use the solid body as the stock, but for some reason I'm just having a hard time getting that thing to pick it up. So I don't know. I think it's me. What do you think, Eric? Let's see. We'll run a simulation here. You're running. Yeah, I just don't think it's picking it up, but that's okay. We'll have to figure out what that is when we're bringing them over. But essentially, using the stock wizard here, you could use a solid body. Let me see if I can explode it. All right, so that broke a bunch of stuff. Let's see if it'll let me select it. Okay, I can select it now. So it must just be something about it being stitched together that it doesn't like.
Mhm.
Because there is a change in the geometry, you can see the association is broken and all these flags come up. This is really nice. You might call this a dirty operation or a dirty feature.
Mhm.
Essentially, it's indicating that we need to reselect our geometry here because we broke the body, right? And it not the edges. It was able to retain the edges, but the mesh, it said it don't like that anymore. I don't know. I just re-window picked it. I can recompute it, and that should update it. It wants the stock, so let's set
Mhm.
this up as that. Calculate. Okay, perfect. This, let's compute. Perfect. Okay, back plot here. We can see what's going on. Perfect. Okay, simulation. Guess what it's going to be, Eric?
There you go.
Perfect. That's
Yeah.
right. Okay. All right. So let's turn the workpiece off. We can look just at the body, right?
Yeah.
Okay. And then we can simulate this through. All right. Now, our tool here is just kind of like a made up tool, right? I mean, maybe this is your tool, this is your flutes, this is the shank, this is the holder. Let's go in here and make some changes, Eric. Okay. So if we come in here and we want to edit our tool, this is different than previous versions. If you're new to Bobcat, it doesn't matter. If you're a previous user, ran older versions, we've made some changes here. We definitely would uncheck System Tool, and we're going to go to Modify Tool.
Hmm.
Okay, this window will pop up now when we want to modify our tools. And so what we're going to adjust is our flute length here. So quarter inch flute length, 16th, right? Okay, this is the ball mill. Okay,
Mhm. Mhm.
this is the protrusion length. This is how much it's hanging out. This is your hangout from the bottom of the cutter. Okay, so we're gonna make this. We're gonna make it 475, like really short. Okay, and then add a holder. We're gonna just put like a quarter-inch holder on here. All right. Yes. Finish. Okay, so now we're gonna recompute. So what we did here is we just edited the tool. and then recomputed the tool path. It didn't really make any difference with the tool path, but you definitely can see how the tool is looking a little bit different now. Okay. So kind of stubbied up here. A lot of times, smaller radius tools like this, there may be, a contoured profile. Eric, how would we describe a tool that just wasn't a straight diameter?
That wasn't a straight diameter. Are you talking
Yeah.
like a tapered tool?
Taper tool, we have a category for it, but what if there was
Mm-hmm.
some other weird profile that represented both the flute and the shank?
We
Could a
we
user?
could yeah, we could represent a like a form cutter,
Correct.
right?
Yeah.
Yeah,
Yeah.
yeah. All you have to do is define it by creating the sketch of the profile, and then you'd be able to define that as custom geometry for your tool.
Yeah, if that's something you guys want to learn about in an upcoming training event, let us know below. Just comment form cutter or special, custom tool profile, and we can get into that. Right? Okay. So one of the topics we had here today has to do with the tool holder. Right?
Mm-hmm.
Okay.
Mm-hmm.
So if we get through here and we look at this, I don't. It won't even do that section over there. Right? Let's blank this one out. Let me make sure this other one is blanked out. All right. So in this case, it's trimming it out automatically. It knows. See how all we did was adjust the holder and it knows. Now, another thing that's worth noting here is that, I am able to modify this tool while it's still in the job. This is something previously you weren't able to do. So I'm going to change the hangout. It asks me if I want to update all the tools, and then it does it. And then now you can see how I changed the shank of it, right?
Mm-hmm.
Okay. Now, um, the workflow that I used here was going through deburring, editing the feature, then going to the tool, right? The new workflow would be, in Rhino, you can pull up this menu down here. You can go to the tool tree. This will show you the tools that are being used in the job and the features that are associated with them. I can then go to that tool specifically and just edit it versus going through the feature to edit. Okay, so just a little bit different of a workflow, right? Okay, we'll go back to the cam tree. We're gonna backplot this. So we changed the tool there, and you can see that it's doing collision checking, and that's the reason why I'm going through this, Eric, right now. Is deburring is a mill premium tool path, right? And
Mm-hmm.
this one you can see how it's automatically trimming out the tool path, right? Okay, so if the tool holder is colliding with the part there, it's trimming it out. Okay, if we want to adjust our tool to say, because maybe you just want to use the tool that you have, but make an adjustment to get the clearance you need, right? So
Mm-hmm.
how would you do that? You would go to that tool tree, double click, edit that tool, and then maybe you say, something like that. Now, there's just like in all scenarios, there is a ratio like to hang out where you're going to start getting, going to get deflection and things like that. Okay, so we can't just stick the tool out as far as the software will let us show. Okay, but here you can see by changing the tool, you know, um, it has to do a different approach in order to come in there and be able to machine those areas. Now, this is also where we start talking about, you know, using multiple axis or a fourth axis or a fifth axis in order to gain clearance. If we make this a 5-axis routine, if you add a 5-axis machine to run this, essentially we'll be able to tilt the tool out of the way, so we can use a smaller tool holder, or a stubbier tool in order to cut the same feature, right? We can go back to the tool tree here, go
Mm-hmm.
back to this guy. We're going to modify that to a much smaller number. Okay. Feature scrubs up dirty, okay. We're going to recompute it, and have it update. And what we should see, my expectation is it's going to tilt away. Okay. So we'll see how the tool tilts away now in order to give us clearance on there and here and here. Right. So I don't like that it appears those are cutting, like one's cutting one direction and one's another direction. We did, or it might just be what I'm. Yeah, okay, they're all cutting the same direction. That's it. A lot of times we're looking at. No, that one's cutting the. It appears that it's cutting the opposite direction. So that's something we may want to look at is what direction it's cutting because we want them all climb milling.
Hmm.
But again, depending on your machine, you can use different tool paths to tilt away, and unlike the standard three-axis tool paths, the advanced tool paths, they really uh, the multi-axis surface-based toolpaths give you more control, but we have done some things with the three-axis toolpaths that enable additional control as well, especially if you have a fourth-axis machine. Okay, right here, when I'm in a three-axis job, we don't see any additional multi-axis machining. We don't see tool tilt control, okay, based on the job. There's a three-axis mill. But if I change this to a five-axis mill, and I come back to this same feature, okay, we're going to see multi-axis posting now. So this way you can control some of the multi-axis scenarios in three-axis routines, right? The other thing we're going to see is tilt control too, but you're not going to see it in the standard 3D toolpaths. You'll see them in the Pro 3D toolpaths. So something like an advanced, let's see, so advanced planar, advanced Z level finish. Let's do the advanced rough, right? Okay, so now we'll see tool axis control, tool axis control, tool axis control. All right, so tool axis control, essentially what this is doing is this is letting us use our three-axis routines as four-axis or five-axis routines by using gouge checking and auto tilting. Okay, and we'll get into that more through the additional sessions through the year. Okay, but because part of what we're talking about today is deburring with chamfer tools. Okay, so we went through some of the deburring options, right? And then we start talking about tools and editing tools and holder collisions. Okay, that's the other thing that we have here is being able to avoid holder collisions, right? So our three-axis routines, sometimes what ends up happening is the tool is going to run into um, the tool holder may run into the part. Okay, and it's not always clear when you start programming the job, whether that tool is going to run into the workpiece or not, right? It's not always clear. Now, when you backplot it, one of the tools that you have to check things, you can get to a specific view and, be able to see what's going on. We can see that's inside of it, but there's no necessarily a color change or any other indicator that there's a collision, right? Okay. But when we go to transparent, it does become a little bit easier to see because there's a change of color there. Okay. So we want to eliminate the tool running in there. Now we could, like we did in the other example where we went in to the tool tree. Okay. Um, we see that this tool is being used here, right? So we can come in and then make an adjustment to this tool, make it larger or smaller, okay, and then be able to update the tool path with a recompute. And then we'll go back and backplot it over here. Okay, and we can see how we can start changing the hangout in order to try to combat this collision here, right? Okay, so dynamic holder checking is pretty helpful for 3D, and to turn it on, we're going to find it in the gouge check. Okay, under the gouge check here, we're going to turn on with feature geometry, tool and holder. No, I'm going right into tilt away. I'm sorry. This is how you would tilt the tool away using a gouge checking method. In this example, we're just looking at holder checking, so we don't have to turn the gouge check on. We come over here where DHC is. Okay, we're going to check with the machining surfaces, and we're going to say only output where it won't collide. We check those two things on. We recompute our tool path, and my expectation is it's going to trim away where the tool can't fit, right? So that's exactly what we see is where that collision would be. Now we're trimming away that tool path Okay, so that we're not running the holder in there. And I think this is pretty powerful, especially when you start staging a series of operations, larger tools stepping down, and being able to use this as a template. Okay, so that was a little bit about the tool holder, collision checking dynamic holder, and how you can utilize that. I know we talked about the edge braking. The new function of that was the spiralized and the chamfer tools. The last one we have here, Eric, is the feed rate control for equidistant. Do you have that sample file already?
Yes.
All right, so I'm going to
Uh,
stop sharing and pass it back to you.
okay. Let me open that one here. Equidistant with toolpath. Okay. There we go. I think we've got it up. Are you able to see the part file here?
Yep.
Okay. So we've got the equidistant toolpath. Now,
All
was there
right, so
certain? Yeah, go ahead.
let's okay, three things. Where is it? What does it do? How do you use it? Okay.
Yeah.
So we're talking about feed rate control for equidistant. Where is it?
So with equidistant, we start with under the machine setup. It's under mill 3-axis. Under the machining strategy, it's here with your 3-axis pro features. Your equidistant here.
Okay.
And if I go to the 3-axis feature, I'm sorry. What was this? What was the setting you were wanting to highlight here?
Feed, feed rate control.
Feed rate control. Now, is that the advanced feed rates you're referring to?
It is
Okay.
one of the biggest things that what's going to impact your machining for 3D.
Mm-hmm.
You're trying to do surface machining. It's contoured. What are things that are going to impact that? What do you have to pay attention to? How are you going to get a precision part? How are you going to get it done accurately? How are you going to get it done, efficiently, without taking too long?
Mm-hmm.
And a lot of that comes down to really understanding your geometry. That's a really big part of it, is to understand your geometry. What are the radiuses, what are the taper angles, what are the depths that you're dealing with, right?
Mm-hmm.
Okay, so that's number one. Number two, you got to pick the right tool path for it based on the curvature of the geometry and everything else. If you move your screen over a little bit here, Eric, and
Mm-hmm.
we show the part model, you'll notice that there's like a contour and there's inside corners. Okay,
Mm-hmm.
so we're doing some contour machining. We're using equidistant, which is a great catch-all. We want to optimize our parameters in order to efficiently run this. Okay,
Mm-hmm.
and your feed rates are one of the things that you're going to use to optimize the job. The spindle speed, the feed rate, the depth of cut. Okay, so what's something we know everybody deals with 3D machining when you're dealing with the corners? What do we know, Eric?
Well, making sure the tool will be able to fit into the corners with no collisions.
Okay, yeah, it's got to fit in the corner. What else? What do you have to do if I'm driving a car and I'm going around a tight corner?
Mm-hmm.
If I'm driving 100 miles an hour and I got a tight corner, what do I got to do in the corner?
Slow down into the corners.
Hell yeah,
Yeah.
otherwise you're going to be in a ditch,
Yep.
right?
Yep.
In with 3D machining, it's the same thing. When you get into the corners, that's where the load is on the tool. So you got to slow it down. And lots of manufacturers run at the safe feed rate, the slow feed rate for the whole job, because the speed rate doesn't speed up and slow down, and they don't want to break tools, and they don't want to have to cut the part again. They know it's going to load up in the corner. They just run the whole job slow. It takes longer than it should. It's costing shops money. Okay, this is a big feature for 3D. You can now change that feed rate, speed it up, slow it down automatically, where Eric is showing you here under the advanced feed rates. Everything feed rate you're going to find under advanced feed rate for 3D Okay, there's the convert to rapids. That's for machines that do dog legs. You can remove the dog legs and map it to a high feed. You probably, I can't see it on the screen here, but it's a feed percentage for your lead in and lead out. So if you're on a heavy cut, you can slow down your lead in or speed up your lead out move. But
Mm-hmm.
the one that in previous versions, we added the up down feed rate, which is just below that one, Eric,
Yep.
up down.
Yep.
The up down feed rate allows you to set how fast it's going when it's up cutting or how slow it's going when it's down cutting, or vice versa. You can turn these up or down by percentage for up or down cutting. But the newest one, which was just released for Bobcam for Rhino and is available for Bobcat Cam and Bobcam for SolidWorks, is the corner slowdown for equidistant. And this is a big game changer for a lot of people. Anybody doing tooling, if you're doing you're cutting 3D parts themselves. Let's say that like machine components, something that could be used in an engine or a hydraulic system or pumps, or maybe you're a sheet metal manufacturer and you're doing things with the tooling for the brackets and enclosures or panels, or maybe you're dealing with castings,
Mhm.
engine blocks, transmission cases, pump housings, anything injected molded plastics, covers, housings, enclosures. Like this is the kind of stuff that you're going to be getting into, and it's 3D, and you run into the same problem with 2D machining with corners. You want to slow it down. We have corner slowdown for 2D. Now you have it for 3D as well. Use this override to change the feed rate. Maybe what you should do, Eric, is go into the tool and change the feed rate to 100% so we can make it really easy. And then we can turn the minimum feed rate down and post it and see how it slows down in the corners.
So you're saying like a
So
cutting and plunge feed rate of 100 interesting?
set the cutting feed rate at 100, set the plunge feed at 50, so they're just round numbers and it's really easy to see. There's only one up down really in this equidistant, so there's only going to be one plunge move. Okay. Let's have it turned all everything off to begin with.
Okay.
Just uncheck that one. Okay, uncheck those,
Yep.
compute it, post it so we can see the feed rates. All right, so we can see the feed rate of 100 there, and then we can see. How are you zooming in and out like that, Eric?
Yeah, so that was actually something I messaged with our tech support team a while ago. Something I saw in like 30 and 31, where you can hold control and use the scroll wheel. Kind of another function, you use like when you're trying to see something in Google Chrome or something, trying to enlarge. You can use your Shift key and use a scroll wheel. I wonder if you can do
I
that.
love it. It makes it easier to read the code,
Yeah.
and I think we made it recently where you can even change the font of the code as well if you
Oh,
have a
cool.
preference for that.
Nice. Yeah.
But now that you zoomed in, we can clearly see there's the 50 plunge, the 100, and if we scroll down through the code, are we going to see any other feed rates?
We shouldn't up maybe at the end the feed rate going up, but that's about it.
Okay. Yeah, I mean, the one down, one up. Okay.
Yeah.
So now let's go turn that other option on.
Okay. So we'll go
And
back
then,
to the cam tree.
yeah.
And so just the up down,
No, let's just do the corner one.
the corner slow down. And you want to
Yep.
set it to like 50 or
Or, yeah, undo the up down and just check on the corner slow down. And yeah,
okay.
set it to minimum feed rate 50%. So we want to be at 50 inches a minute or greater.
Right.
Between 50 and 100 is what we're saying will cut. So in the corners, the slowest it would go would be 50, right?
Right.
Um, so if we repost it, which you just did, or I'm sorry, you recomputed it,
Mhm.
repost, and then now when we look at the feed rates, we can see they ramp up and ramp down. Now, we want to show you the code so you can see the code, how it's going 90, 80, 60, 50, 75, 80. So it's ramping up and down in the feed rate, but it's also helpful in your back plot. You can see what the feed rate is as well. Okay. So
Mhm.
Eric, if you get the back plot going and then we look at it in one of the, maybe advance it till it gets a corner move, we can show how the feed rate is changing, in that corner. So again, where is it? What does it do? How to use it? Okay,
Yeah.
so let's go back. Where is backplot? If you're just joining us, you're catching us late, or really at any time.
Yeah, so
Uh,
we expand the feature here and we right click on any operation we want to backplot individually.
Perfect. So we open that up, we right click, we go back plot. All right, that's where it is. Okay, now you can use that slider to advance it, and we're looking for some corner moves. Where does it show the feed rate?
So down here towards the bottom here, feed rate of 67.5 inches per minute.
Okay, cool. So as you step through that, does that number change?
It should, yes. And now it's slowing down to 58, ramping back up as it's going across there.
Perfect.
Almost at 100, going 98 inches per minute. Then it'll slow down into this corner and then ramp back up once it gets to this planar tool path at the top surface, flat surface here.
Awesome. Awesome. Well, I know that those are the topics that we had to cover here today. Did you enjoy today's event, Eric? Some
Yeah,
of these different
always.
ones? Yeah, right.
Yeah, there's always something new to learn in the software for sure.
Cool, cool. So what do we have coming up next week?
That's a good question. I know that we're still working in Bobcam for Rhino version 3 here.
Right.
Are we up to 4-axis next week, I
I,
believe?
what I think the schedule does show 4-axis, and what I think would be a really good one to do would be 4-axis for routers.
Okay.
So I think maybe we can ask some of the people. We can send a survey or something and see if you guys have some feedback on it. If you'd like to see a 4th-axis training event for routers next week, let us know. I want to show the turn mill. Turn mill is super cool,
Mhm.
and rotary, advanced rotary. I've had a lot of luck with that. What would you want to show for 4-axis, Eric?
For 4-axis for routers, I know that there's a lot of guys that do engraving and pocketing for inlays for pool
Cool
cues is
cues,
a very
big
yeah
one.
very specific one. Yeah,
Yeah, cool.
but
All right.
yeah,
Well, I don't know. That's all I have for today. You got anything else you want to share with them?
I think yeah that's all I had too.
Awesome. Well, we'll get back some time, and we look forward to seeing you guys next week.
All right, thanks everyone for joining us today, and have a great day there.
Bye now.